Okay, today you already should have done your pre-assessment for waves and completed that. And now I need for you to do Science Notebook number 1. Please make sure that if there's any damage at all done to your Chromebook before you got it, that you reported it to the substitute, because you will be held responsible. You are to get your Chromebook number, not somebody else's, and you are responsible for what happens to it while you have it. Alright, so if you would please go to page 93, that's page 93, and you're going to put Science Notebook number 1. What are the properties of waves? Today's date, which is March 1st of 18. Please write down the time, the weather, and the color of the group that you're in. You should be in your assigned seat. Alright. So, let's go ahead and get started. A wave is a disturbance that transports or carries energy. This is an important thing for you to get, is that the waves transport energy. Energy moves in waves. Matter does not. Alright, so let's draw a wave. This is a transverse wave. Do the best I can here. This is the crest. This is the trough. If you draw a straight line through the middle, this is the rest point. So for instance, if you had a still pool of water, this is where the water surfaces, and then you drop a rock in and it creates these waves. The distance between the crest and the rest point, or the rest point and the trough, that is the amplitude. So take a minute, maybe underline, oops. Amplitude is this measurement. Rest point is this. This is the crest. And this is the trough right here. Alright, moving on. You know you can pause this whenever you need to. So, the parts of the wave sometimes give you information. For instance, oops, we missed one. Alright, and if you take the distance from the crest here to this crest here, that is a wavelength. You also can measure wavelength trough to trough. Any point on one wave to the corresponding point on the other. Okay, so you've got your parts of a wave. The crest is the top of the wave. The trough is the bottom of the wave. The rest point is when the medium isn't transferring energy. You have the wavelength, which is the distance between one point on a wave and the same point on the next consecutive wave. Now you have the amplitude. And it's the measure from the rest point to the crest or the trough. Okay, in a sound wave, amplitude equals volume. Alright, go ahead and pause this until you have all of these notes. And remember, waves transfer energy, not matter. So the matter through which a wave travels transfers the energy, but the matter itself doesn't move. Okay, pause this till you're done, and then continue to your left-hand assignment. Okay, here's your left-hand assignment. This needs to go on page 92. Here's your scenario. Nicole and Grayson were on a cruise ship with their family in Glacier Bay, Alaska. They have been learning from the guide about calving. This is when a huge part of the glacier breaks off and falls in the water. Wow, said Grayson. I bet it makes quite a wave, bigger than the cannonball dives I do in the pool. Just then they noticed a small boat between them and the glaciers. I sure hope that glacier doesn't calve while the boat is there, said Nicole. It'll push the boat right into us. Don't worry, said the guide. I've seen it happen before, and it never brings the other boat over closer to us at all. Can the guide be right? How will a large wave caused by the glacier breaking off and falling into the water affect the small boat? So for your left-hand assignment, I want you to draw 4 pictures on page 92. Draw 4 pictures to show what will happen to the cruise ship and the little boat when the glacier falls into the water causing a wave, which is calving. In all 4 pictures, you should show the glacier, the little boat, and the big boat, which is the cruise ship, and the water. You are also required to write captions explaining what is happening as the wave travels from the glacier out to the bigger boat. So in picture 1, you should have the glacier, the little boat, the big boat, and the water before anything happens. In picture 2, you're going to show the glacier falling into the water. As the glacier falls into the water, of course, it's going to cause a wave. Please remember that in each picture, you need to have the glacier, the little boat, the big boat, and the water. In the third picture, you should show what happens when the wave reaches the little boat. And in the fourth picture, show what happens to the big boat when the wave reaches it.